So Swami, it is done?
Yeah, now we can start. We can start. Yeah.
Okay, we can start. I think, yeah, it is connected now. Yeah.
Yeah, it is connected now.
Right. Okay, so we'll just start now. Okay, fine. So first I'll introduce the speaker actually, then we will. So good evening to all the esteemed members of the Ocean Society of India, ladies and gentlemen. The Ocean Society of India has taken up an initiative to conduct invited talks as a part of the OSI Webinar series once in every month. And this talk is arranged from eminent scientists, engineers, academic professionals working in the broad areas of atmospheric and oceanic sciences, ocean engineering and technology. And this webinar series is targeted mainly for the students, researchers, scientists, engineers, and working professionals in the field of atmospheric, oceanic sciences, ocean engineering and technology, so various disciplines, with a motive to impart and improve the knowledge benefiting the OSI community. I request all the members to actively participate and get involved in all the lectures under the OSI webinar series that is held every month. On behalf of the Ocean Society of India, it is my proud privilege to welcome today Professor Vimal Mishra, Associate Professor, the Department of Civil Engineering and Earth Sciences, IIT Gandhinagar. So Professor Vimal Mishra will be delivering a talk on the topic Benchmark Worst Droughts in India from 1901 to 2020. So this is a topic of immense importance and having wide socio-economic consequences in a changing climate for India, in particular for the sectors like agriculture, water resources, food and water security. So to give a brief background about the speaker, Professor Vimal Mishra has completed his BTech in agricultural engineering from Chandrasekhar Azad University of Agriculture and Technology and MTech in agricultural and food engineering from IIT Kharagpur. And thereafter he completed his PhD from the Department of Agricultural and Biological Engineering from Purdue University, USA. His research interests are on wide areas such as climate variability and climate change, large-scale hydrological modeling, analysis of extreme events, including droughts and floods, global food and water security, real-time hydrological monitoring and prediction, remote sensing and GIS. So these are some of the areas that Professor Mishra works on. And Professor Mishra is a very active researcher. And he has made valuable and significant contributions in these areas. So Professor Vimal Mishra is also a recipient of the Young Hydrologist Award for the year 2015-2016 from NGRI AHI. He is also a recipient of SN Gupta Memorial Award and lectures from ISH, the Indo-UK Water Center Research Exchange Award, Research Excellence Fellowship from IIT Gandhinagar, and many more. So he was a postdoctoral fellow at the University of Washington, Seattle from May 2010 to May 2012, and visiting professor at Northeastern University, Boston, USA from May to June 2013. So he joined as an assistant professor at IIT Gandhinagar from May 2012 and continued as assistant professor till January 2018. So presently he is an associate professor since January 2018, and his work has been published in the topmost journals, you can say leading journals, such as the Proceedings of the National Academy of Sciences, Nature, Geoscience, Geophysical Research Letters, and Water Resource Research. He is currently serving as editor of Earth's Future and associate editor in the Journal of Hydrology. So with this brief introduction, it is my proud privilege to kindly invite our speaker, Professor Vimal Mishra, to deliver the talk. Also, I request all the participants that the questions and answers can be attended after completing the talk. So they can be posted in the chat box, and after the talk is over, actually we can attend the question and answer session. Thank you very much. So I now request Professor Vimal Mishra to please start the presentation.
All right, so thank you, Professor Bhaskaran, for, can you hear me, Professor Bhaskaran?
Yeah, you're audible, yeah.
And you can see my slides, right?
Yes, it's visible.
So thank you, Professor Bhaskaran, for very kind, introduction. And it's a pleasure and privilege to sort of being able to present my work under this seminar series, run by Ocean Society of India. So what I'm going to do today is I'll give you sort of some idea like what is happening with droughts in India. And, as you have seen my background, like I sort of love to work in the areas of climate and water resources. And when you talk about climate and water resources, droughts become very important to sort of understand their occurrence, their impacts, and how they are going to change in future in response to warming climate. And drought in India have more significance given that our country a large population of our country depends on agriculture, and agriculture is also the biggest or largest water consumer. So roughly about 80% or so fresh water consumption happens in agriculture in form of irrigation. So, if you see past few droughts in the country, you will see droughts normally occur from the monsoon failure of the summer monsoon. So that is sort of mother of all kind of droughts, because there are different kind of droughts like meteorological droughts driven by rainfall, agricultural droughts driven by depletion of soil moisture or soil moisture deficit, hydrological drought, deficit in stream flow, and so on and so forth. But please remember that most of these drought occur because of the failure of the summer monsoon rainfall. Right, and when drought happens, there are large implications like related to water management in agriculture, water management in drinking water supply ensuring, or water management in reservoirs. And droughts are costly because they cause very large economic damage, because they cover uh, extensive spatial scales. The other feature with droughts is that, unlike floods, drought can be long lasting. So if you look at the historical droughts, drought could occur like more than 2 years or 5 years continuously, and they can affect all aspects of socioeconomic life. So in today's talk, what I'm going to cover mostly is I will give you a brief overview, what is drought, then what are the implications of drought in India, and then what are the challenges associated in terms of monitoring droughts in our country. And then we will look at what are the worst droughts that occurred in last 100 or 20 years based on the observations we have. And then how drought may occur or likely to occur in future, and what we can do to sort of manage droughts in India. So all this will be covered in my today's talk. Of course, I may not go in much detail given the very diverse background of audience. So, there are many definitions of droughts, and that's why A drought is a complicated topic, but United Nations Convention to Combat Desertification, UNCCD, has given a specific definition of drought, and that is it's a naturally occurring phenomena that exists when precipitation has been significantly below normal, causing serious hydrological imbalance that adversely affect land resource production system. So if you see here, the key trigger of drought is the below normal rainfall or precipitation, and that will convert or that will affect water availability in rivers, lakes, reservoirs, and that can affect resource production system by various ways like agricultural production, dairy, or other things. The other thing you need to remember regarding drought is that it is a slow onset hazard. So it may take months and months for a drought to develop, and once it is developed, it may persist for a long duration, affecting many different areas, many different regions, and causing different kind of implications, right? So this is a key figure. I mean, if you talk about what is the key triggers of drought, so drought is basically caused by natural climate variability. And so there are two things that basically trigger droughts. One is precipitation or deficiency in rainfall. The other is prolonged high temperature, high winds, low relative humidity, greater sunshine, less cloud cover. So that is basically, these are the favorable conditions to enhance atmospheric water demands, or something we call potential evapotranspiration, right? And that will then translate to reduced infiltration, runoff, or groundwater recharge, and increased evaporation and transpiration. So all this is termed as meteorological drought, because this drought is largely driven by meteorological conditions, be it deficiency in rainfall or very increase or anomalously high temperature. Right, once meteorological drought occur and it persists, then it translates to other type of droughts. For instance, if you have low infiltration, less precipitation, high evaporation and transpiration, that will reduce the soil water or the soil moisture, and then there will be a soil moisture depletion or soil moisture deficit, and that will basically result in plant water stress, reduced biomass, and crop yield, and that we collectively term as agricultural drought. So that is, so when you want to see agricultural drought, normally we look at soil moisture or agricultural production or vegetation health products remotely sensed that can give us idea about plant water stress, right? And then if that happens also for a long time, then we see further impacts of drought in form of reduced stream flow, inflow to reservoir, lakes, ponds, and wildlife habitat. And all this collectively is known as hydrological drought. So here you see that these are the three major type of droughts, starting from meteorological drought, agricultural drought, and hydrological droughts. And all of these, on this side, you can see the time duration. So if meteorological drought prolongs, it can cause agricultural and hydrological droughts. And all these three together can have socioeconomic impacts and also environmental impacts. So for instance, economic impacts in terms of loss in production, social impacts means loss in or reduced income of people, or loss in livelihoods or something like that, and there could be environmental implications of that. So now what we have covered so far, that what is drought, what is definition of drought, how droughts occur, what are different kind of droughts, right? Now, droughts in India, what are the impacts? So drought is basically one of the costliest disasters in India, because it can be triggered by the failure of summer monsoon. It can cover a large part of our country, and it can cause losses or damage in agricultural production, also the employment of rural people, also challenges associated with water availability and water demands. So when it comes about the impacts of droughts, we can categorize the impacts in these three types. One is physical impacts, that is reduction in soil moisture, stream flow, reservoir level, or groundwater. Impacts on agriculture, right? So loss of money invested in farm preparation, seeds, food production, food security, and food prices. For instance, if there is less production, price also goes up. And then social and economic impacts. So as I said, fall in employment in agriculture, reduction in purchasing power, and issues related to drinking water. So I mean, how a drought will affect, or what kind of impacts a drought will have, that depends on multiple things, like how severe drought was, what area it has affected, what was the time when drought occurred, how long it lasted, whether and how intense it was, right? So, but most often we see these kind of impacts. Now, I will discuss like summer monsoon droughts in India. What are the implications with this introduction? Like what I have covered so far was just the introduction about the droughts, right? So as you might have seen pictures like this during the monsoon season, you can see in this picture that there is a rice transplanting going on, right? So what is important to understand that one of our major crop growing season that we call Kharif season overlaps with the summer monsoon in India from June to September. So if there is a failure in monsoon, or if there are anomalies during the monsoon season in terms of active and break spells, you will see that some of these farm operations like transplanting, sowing, or if the crops are standing, they can be affected by droughts, right? But the other important aspects with the monsoon is that every year you will see some areas get flooded multiple times, and some areas may be under drought during the same monsoon season. So what we know from this, that there is a great spatial variability within the monsoon season across the country, not necessarily, or it doesn't happen like rainfall is uniformly distributed across the country. So in any given year, regardless of whether the summer monsoon rainfall was normal or abnormal, you will see some areas were under drought, at least for the part of the monsoon season. So, I mean, if you look at the historical record, the good thing is that we have a long-term rainfall data, very good quality data available from India Meteorological Department, starting from 1901 until 2021. I mean, until recent, we have data, and that rich data set observations give us opportunity to understand that what has happened in the past and what were the impacts or implications. So what you see here in the top panel here, y-axis is drought extent in percentage, means how much area was affected by drought in our country, right? And these are an x-axis you see here, and each bar represents the area affected in a given year. So if you see the tall bars like this is a 1987 drought, this is 2002 drought, this is 1972 drought, this is 65 drought, this is 2009 drought. So we can easily notice that when major droughts occurred and how much area of our country was affected by these droughts. For instance, if you look at the 2002 drought, which was one of the worst drought, that affected almost 55% of our country during the monsoon season, right? And why this drought occurred? Mainly because of the failure of the summer monsoon in that. So there are various indicators to monitor different kind of droughts, like meteorological drought. We use indices called standardized precipitation index or standardized precipitation evapotranspiration index, as you see here, right? So we can, and for agriculture, we can use a standardized soil moisture index. For hydrological drought, we can use a standardized stream flow index. So in drought, this is a problem that we have multiple indicators depending on what kind of drought we want to understand, right? So what I want to show you here is that in 1965, like if you take the 1965, which is this year, right here, what area was affected? So if we make the spatial plot, this is the scale of SPEI. So darker the colors towards black means drought intensity was severe or more severe. Lighter the color means less intense drought. So you see much of the North India was affected by 1965 drought. Similarly, during 2002, once again we see a large part of country, almost more than half or 60% of country was affected. And you can tell that, okay, drought was of course almost extreme and exceptional category, and it affected the western part of country, southern peninsula, and then part of this region, Orissa and Chhattisgarh, right? So we can, this how we can know what area was affected, right? The other thing you can notice here is that when droughts occur during the monsoon season, there is increase in temperature, and that is because rainfall cools down the temperature after the summer, and if there is no rainfall or there is a break period, temperature goes up. So you see that not only drought is there, this area is having almost 1.5 or 2 degree above normal temperature during 1965. Similarly, in 2002, we also see like same areas were affected by positive temperature anomalies or warming. So drought causes the deficit in rainfall or caused by deficit in rainfall, and then there is an increase in temperature, and that can further, enhance the severity of drought. So we looked at how drought affects during the monsoon season, means these hot and dry extremes affect the food production. So in this slide, what we see here in panel A, on x-axis are years, y-axis are yield in kilogram per hectare of different crops like wheat, rice, food grain, and cereals. And you see that one thing we can notice that we have made a lot of progress in terms of, uh, increasing the crop yields, right? But you can also notice that there are dips or anomalies in these time series, and these are mostly because of droughts, right? For instance, here you can see, or this 2002 drought, you can see this dip here, right? All this dip in rice, food grain, and cereal crops. Why we don't see in wheat? Because wheat is not a kharif crop. So this was mainly during the monsoon season. So kharif crops like rice and other cereals were badly affected. The other thing you can notice from panel B to panel B to G is that the combination of hot and dry extremes. Dry extremes means deficit in rainfall. Hot extremes means increase in temperature. And that's what basically happens during the major droughts. Also affect our food grain production, production of rye, wheat, and cereals. And you can see the high positive correlation with rainfall and negative correlation with temperature. So the monsoon season droughts can badly affect food production, and this is well established, right? The other implication of drought in our country is that whenever drought happens, basically, you will have sort of water availability problems, and then people want to irrigate crops, so there is enhanced or increased groundwater pumping. So here you see an example of 2015 droughts that caused significant groundwater depletion in North India, because this drought was centered over the Indo-Gangetic Plain or in a North Indian region where groundwater depletion is already happening. So drought during the monsoon season, caused lot of groundwater depletion in the winter season, followed post-monsoon season, December to March, that you can see here in terms of groundwater anomalies. And it's also affected the soil moisture availability. So not only that affect only during the monsoon season, but post-monsoon season you can also have impacts. In our very recent work, we have shown like how droughts affect groundwater in the Ganga River basin, and what we identified that during the extreme droughts years of 2009, 2014, and 2015, the groundwater abstraction was almost 15 to 20% higher than the normal year. So people start pumping more water. On the other hand, groundwater recharge was almost 10 to 15% lower, and this higher abstraction or pumping and lower recharge because of drought again affect your groundwater sustainability or groundwater depletion in the region, as we have shown for the Ganga River basin in the North India, right? Now, so what we have covered so far in this talk, in the basic, introduction of drought, then what are the implications of drought? And we have seen how drought can affect food production, how drought can affect groundwater and soil moisture. And also, when drought happens, groundwater pumping also increases and recharge goes down. So that puts lot of pressure on the groundwater sustainability. Now I will focus in this part of the talk, I will focus on what are the challenges in drought declarations and associated with spatial and temporal variability during the monsoon season. Now, so if you look at this long-term data of rainfall anomaly on y-axis in percentage, so that means what was the departure from the mean, and red colors indicate droughts, blue indicates floods, and gray bars shows the normal years. And then if there are circles, you can see El Ninos. If blue circles, those indicating La Nina. So you see there have been a lot of droughts starting from, in this data start from 1870, goes until 2020, and I have taken this from Roxy's website. And you see like drought have been occurring, always, regardless of climate change or not climate change, because droughts are part of natural climate variability. Now, climate change can further intensify them because of the warming, but drought has been occurring, and there have been some very very major droughts like you see here occurred 1870 or 79 or 78. I think it is 1876, 77, that also caused famine in our country. If you read the history, you will see that this drought caused famine and millions of deaths occur because of this drought. But if you look at the recent period drought, after 1970 or so drought, there have been several droughts caused by El Nino, and they because of rainfall anomalies exceeding more than sort of 20% also sometimes. So and now before moving forward, I would like to state that what are the long-term changes that we have witnessed or we have seen, like what our observations are suggesting us how rainfall changes in rainfall have occurred. So total rainfall, if you look at the 1950 to 2016 period, this is I mean few years back, you will see that Gangetic Plain, part of Western Ghats, and some other regions like Northeast India, there has been considerable decline in total rainfall. More remarkably, there has been very, significant decline in low intensity rainfall. So low intensity rainfall has almost declined across the country if you see in the map, right? On the other hand, high intensity rainfall has declined over the Indo-Gangetic plain, but it has increased in parts like in the western parts of India, Gujarat, Madhya Pradesh, Rajasthan, and also some of the eastern parts like West Bengal and part of northern Andhra Pradesh and Orissa. So this is a picture showing, I think this is this year, 2021, drought in Bikaner, cattle die of starvation, and food prices goes up like 150%. So what I want to highlight from these pictures that drought don't affect only the natural resources, but when droughts occur, not only humans, but animals are also badly affected because they don't get food and fodder that are normally available in normal situations. On the other hand, we have also seen pictures like this during the same monsoon season, like after a drought, a few days of heavy rainfall in Odisha caused floods. So if you recall this year, Odisha was under drought in August and September, and then in the late monsoon season or in late September, 4 or 5 days rainfall caused massive flooding in the region. So that creates a problem in sort of drought monitoring, because when we say there is a normal summer monsoon rainfall, we do declare that based on the all India average. So we don't look at, and we also declare that based on the total rainfall from June to September. So, but there can be a lot of spatial anomalies and also temporal anomalies. As you can see here, 30th August 2021, this is the situation of standardized precipitation index from our India drought monitor. And if you see in August, Gujarat, Odisha, and these parts were very under severe drought, right? Based on 1 month or 2 month standardized precipitation index. But if you see 30th September 2021, you see this same regions got under extreme wet conditions. And that tells us that why we don't need to sort of average everything, spatially and temporally, to declare that whether monsoon was normal or not, because this drought must have affected various aspects during the August, and these floods also affected people badly. So both kind of extremes, when we take the mean of sort of drought-like situation or flood-like situation, it may give us a condition that is normal looking, but essentially these extremes affect both kind of these extreme affect various aspects of life and also resources. So this is again from IMD slide, and this tells us how monsoon progressed in different parts of country. So blue is all India, then northwest India, northeastern India, central India, southern peninsula, and on y-axis we have the departure in rainfall, right? So if here we see 10, so that means 10% more rainfall occurred in June, 7% less rainfall occurred in July based on all India average, 24% less occurred in August. So you see here July and August were below normal. And in September, there was again 34% surplus. So now if you average this out, you get almost only 1% deficit. But what is critical or key here to see that this 24% deficit in August and 34% surplus in September affected various aspects because of droughts and floods in the same season, but at the end the monsoon was normal. So what it highlights that we need to sort of monitor spatially and temporally the extremes or hydrologically extremes that can capture the response of or the implications and impact occurring in different regions. You can see week to week percentage departure in rainfall here also. So you see starting from 23rd June to almost end of August, it was very, very less rainfall. Okay, let me check the time before I move so that I can keep up the time. So now I'll focus on benchmark burst drought. So that gives us a sort of basis that why we need to not only declare droughts based on the combined rainfall in the monsoon season, but we have to monitor that continuously. So for instance, there could be burst drought can occur in June and that can affect, or they might have different implications, or July or August and September. So if you look at the history of last 120 years, what were the worst benchmark droughts? And why benchmark? Because we can then relate the coming droughts in future with these to understand how severe a particular drought was, right? So if you are not familiar with the categories of droughts, droughts are normally, severity or intensity of drought is measured using categories that are like abnormally dry, moderate drought, severe drought, extreme drought, exceptional drought. And these are based on probability of occurrence, right? If I say exceptional drought, that means there are 2% or less probability of occurrence of that kind of a drought. And these colors indicate basically the category of drought. So if you see like this color, you can see the region is affected by exceptional drought. So as I mentioned earlier, that in drought, there is a need to sort of integrate not only the area covered, means how much area was affected, but how a particular area was affected under different categories, right? So for instance, if I say 20% area was affected by drought, and if all 20% was affected by exceptional drought, impact would be very different than if that region was affected by abnormally dry conditions or moderate droughts. So here we use an index that called Drought Severity Coverage Index, and that integrates severity and area of drought. And basically it uses weightage of area under different categories. So for instance, area under exceptional drought will get weight of 5, area under moderate drought will get weight of 2, and then you multiply the area affected by these weights, and then sum that up, and that then you can come up with the index called Drought Severity Coverage Index, and that will give us like which time or which year the worst severity and coverage of drought occurred. As you can see in the bottom, this is a time series, and you can see that this was the period when burst affected, or the large the drought that affected a large region with high severity occurred. So we use this data of 120 years to sort of identify drought or estimate drought severity coverage index, and based on the area affected under different categories. Please note that these bars with different colors indicate 5 different categories of droughts, and this green line gives us an idea about drought severity coverage index estimated by that. So we identified that June 1923 was the worst benchmark drought that occurred in June in the entire record. Similarly, in July, it occurred in 2002, and in August in 1937, September 1907, and in entire monsoon season, if you rank the drought, the burst drought or burst benchmark drought was 1980, and it's from 1901 to 2020, right? We also look at in top 5, basically based on DSCI, top 5 or top 5 burst drought in 120 years, and which areas those affected. Here the color scale is standardized precipitation index. Again, the dark colors, dark black colors showing exceptional drought or extreme droughts. And you can see that different regions. Similarly, in 2002, you can see how much area of the country was affected, right? So we can get these droughts for June, July, August, September, individual month of the summer monsoon, and for the entire monsoon. So for instance, if you look at the July 2002, right? It was almost 80% of the country was affected. On the other hand, if we look just entire monsoon season of 2002, then we get this picture, right? But in July, it must have been devastating. So that's why it is important not only look at the end of the monsoon season, but continuously what is the condition and how it is progressing. Now, after doing that, since we have long-term data of DSCI for each month of the monsoon season and entire monsoon season, what we did, we fitted distribution, probability distribution, and we identified that what was the return periods of these benchmark burst droughts. And we developed sort of these curves that can be used to estimate, the severity or how any drought in a given month of a given monsoon season compares with the benchmark burst droughts in terms of severity and coverage. So these curves can be used sort of to understand in real time or near real time that what is the severity of current ongoing drought in a given month. We also looked at that which is the most important period for drought. So in this, we used Drought Severity Coverage Index for entire monsoon season and for June, July, August, September, and we sort of estimated relative contribution. So for instance, June DSCI only contributes about 7% to overall monsoon season droughts. On the other hand, July contributes almost 47%, followed by, September and August. So that tells us that if drought happens in July and a worst or the very severe widespread drought occurred during July, there is a likelihood that it will cause entire monsoon season drought, and that is because July is the important month for the summer monsoon season. And we also looked at like what is the ocean sea surface temperature or what was the atmospheric anomalies during these worst benchmark droughts. As you can see here, we have compared like different indices like sea surface temperature anomalies in different regions like Nino 1.2, 3, 4, 3.4. And we also looked at sea surface temperature anomalies of 3-month mean like April, May, June for June droughts, May, June, July for July droughts. Most of the droughts were linked, of course, with the positive sea surface temperature anomalies over the Pacific, but not all. And those which were not linked was mostly affected by other atmospheric, anomalies that we have discussed in this work. Now, what we can expect in the future drought under the warming climate? So I'll very quickly cover this in interest of time. So what we have seen so far based on our work that the nature of drought is changing as climate is changing. So under the warming, we are going to see, or we have already started witnessing flash droughts. And flash droughts are nothing but, droughts that become or that intensify very quickly within a 2 to 3 week time period. So why does it happen? It happens because if there is a break in the monsoon season, you have a soil moisture, but temperature goes up because of there is no rain. And then if you have, warming because of climate change, that increases the atmospheric water demand during that period quite fast. And because of this land atmospheric coupling or feedback, you see very rapid depletion in soil moisture, as you can see here. And this happens in 2 to 3 week time period. And these flash droughts are going to be, more frequent, more intense, and in large numbers under climate change. And we have shown already in one of our papers, like here you see the frequency of flash drought 1971 to 2000 in green bars, and these are the pentards during the monsoon season 30 to 55. And then if you look at the end of century based on some climate model simulations, you see that how this frequency is going to increase in the future, right? So the nature of drought is also expected or projected to change in the future. Now, how we can tackle these problems? I mean, there are of course, not a single solution. We have to develop adaptation mechanism, especially how we tackle or how we manage, mitigate droughts and negative implications of that under the warming climate. But drought early warning system or real-time monitoring and forecast at least gives us some idea to get prepared. And we have been working in that direction. So we have developed the India Drought Monitor that is operational. If you Google, you will find out the link, and we update this every week once. And that will give you a condition that which area is affected, whether area is going to remain affected in drought in next 15 days or 30 days, or there are forecast, or there is a forecast that drought can recover. So in summary, I think this is the last slide of my talk. In summary, what I have covered, I have given you like introduction of droughts, implication of drought in India, especially during the summer monsoon season, how droughts affect food production, water availability, groundwater sustainability. Then we looked at the challenges in drought monitoring, where I discussed like why it is important to not only look at the end of the monsoon season, but also looking at what was the nature of occurrence of different hydrological extremes during the monsoon season, and which regions were affected, and then we looked at the worst droughts in the history of India, and we developed curves that can be used to sort of compare the current droughts with the benchmark droughts, and then what we can expect or how the future may look like when it comes about droughts, and then how we can tackle droughts. Of course, there is not a single solution. We need to make much more effort, but drought monitoring, early warning system, or more robust information in terms of impacts, that how, if drought is going to occur, what would be the impacts. And when we talk about impacts, we should consider not only economic impacts, but societal and environmental impacts also. So now people are moving towards impact forecast rather than, forecasting climate or hydrological extremes. Because if we forecast impacts, that gives much more better information to policymakers that if something happens, what could be impact and what are the measures or proactive measures that we can take to tackle these challenges. So I'll stop here. Thank you very much for listening me, and if there are questions, I would be happy to address. Once again, thank you, Professor Bhaskaran, providing me this wonderful opportunity. Thank you very much.
Thank you, Professor Vimal Mishra. It was a very excellent overview on the flood and drought on a climatic perspective. You have given a very elaborate details of what happened in the last maybe a century, or the various drought and the flood events in India, and what are their socio-economic impacts. And you have also touched upon the summer monsoon droughts in India, specifically on the monsoon season deficit or the droughts in the specific particular years. Very interesting part to see that. You also related with the intensity of rainfall, like the low intensity rainfall, the decline in the low intensity rainfall, and also on the high intensity rainfall over the eastern and western sectors of India. And also on the standardization of a precipitation index. So these are very really interesting points that you have mentioned. And later on the later part, actually, you have also touched upon the flash droughts that is happening, and its frequency of occurrence in a changing climate. And yes, I do agree that it is a very, very important topic which needs to be given more emphasis, specifically in tackling the droughts. And the drought monitoring system that your team has developed is a very, very useful tool. And I believe that the policymakers make use of it. and it will definitely benefit the country. So it's a very important and very interesting talk. And let me just see if there are some questions. Because I have just noted down some few questions that I wanted to, out of curiosity, I just wanted to ask, because it's a new topic for me also, and it's quite interesting to listen to this. You mentioned about the persistence of droughts can be for a longer duration as compared with floods. The persistence, the development as well as the persistence of droughts can be of a longer duration. So what are the possible reasons why it is so? Why is it that the droughts actually take a longer time for a recovery?
Yeah, so I mean, that's a nice question. So as I mentioned, like if you look at the conventional droughts,
Yeah.
they develop over the months of time period, right? So
Yeah.
like you have a monsoon failure, and then after monsoon failure, you will see the droughts occurring, like in terms of soil moisture, stream flow, or reservoirs. And
Okay.
you know, so system gets lot of time to sort of get drought set in, and that's why we call slow onset disaster. Drought is a slow
Yes.
onset disaster. But once that is in, you know, then you need a significant amount of rainfall. So for
Yeah.
instance, you have created a deficit over the very long period, deficit in reservoir storage or deficit in, you know, stream flow that has been created over a long period. So now, normally what happens, with a spell or two of rainfall, the recovery doesn't happen. So it
Yeah.
remains there. So for instance, you got a rainfall that was not sufficient to, you know, to terminate drought. Then what will happen after that rainfall? Once temperature goes up, that moisture can also be very quickly depleted. So you need a very high amount of rainfall or multi-day rain event that can terminate that drought. And that's why, you know, once a severe drought, large, you know, severe widespread drought occur, it may take months to sort of terminate. And that's why we say it has very high persistence in the
Yeah, I
system,
think
has
yes,
a high validity.
that's a very good point actually that you mentioned, and yeah, it was a yeah, I got the point actually that you're trying to mention. Yes, and another thing actually is that you also mentioned about the rainfall variability across the country, and of course it can be attributed to the climate change in one way. I was also reading some literature that which mentions that the strength of the Indian summer monsoon is weakening.
Mm-hmm.
The strength of the Indian summer monsoon is weakening over the last 2 decades,
Yeah.
approximately. So how does it really? How does this actually affect the impact on the flood and drought events? As any?
So, I mean, if you look at 1950 onwards, there
Yeah.
are parts of the country that have been receiving, you know, declining or have been witnessing declining trends in summer monsoon rainfall. And
Yeah.
those are predominantly or prominently located over the Indo-Gangetic Plain, Western Ghats, Northeast India,
Yeah.
right? So these are the
Yeah.
regions where rainfall has been declining.
Yeah.
Now, I mean, if you look at the climate change projections,
Yeah.
majority or most of the models will project that as we are moving towards warming climate, there will be an intensification in summer monsoon rainfall, right? So we
Yeah.
are expecting more rainfall, but in terms of observations, it is not happening, at least in some part of the country, and
Yes. Yes.
that is probably because, you know, GHG emission is only one part of this entire big puzzle, and there are other, you know, forcings, radiative forcings, or other factors that affect the monsoon circulations, like aerosols, like land use change, like human interventions over the land, like irrigation, and so on and so forth. So, so I mean, in summary, we can say that there are parts of regions where monsoon has been declining, and it has declined quite significantly, especially over the Gangetic Plain and over the, two other regions that I mentioned.
So, yeah, I think 1 minute. I'm just watching the chat box. The new questions have not come. So one more question I just noted down was in one of the slides where you showed the histograms on the frequency of the droughts starting from 1960s until present. I observed in one of the in that particular slide that the frequency of severe droughts, the frequency of very severe droughts, which is actually the length of that. Yeah, exactly this one. No, I think it is not this one. It may be another slide actually, where the histograms are there. Somewhere in the beginning, yeah, in the beginning part.
This one?
Yes, exactly. The top figure, which is showing the percentage, the on the y-axis.
This is area under drought.
The area and okay. This is area under the drought. Maybe I think maybe it may not be this slide. It may be other slide actually. Maybe the other slide.
I think frequency slide I have this one.
The frequency slide, exactly. The frequency slide. Now, what I'm saying is actually that during the 1960s and until the end of 1980, there has been an increase in the frequency of severe droughts as compared to the recent. But one another observation that I'm seeing is that number of droughts have increased since 2000. The number of droughts, the number of drought events have increased.
Yeah.
So I think that basically says that from 2000 onwards, the events are actually increasing. Though it may not be that severe, but the number of droughts are more actually.
Yeah, and that is partly because if you just look at droughts based on rainfall, this is partly because a large part of our country is witnessing declining summer monsoon rainfall.
Exactly.
So like if you look at frequency, for instance, over the Gangetic Plain, you will see that there has been an increase in the frequency of droughts over that region, and that is attributed to declining summer monsoon rainfall.
And one more thing, this precipitation, the standardized precipitation index, one map actually of standardized precipitation index. So this has been estimated using the average or the moving average, this particular figure.
Yeah, so this we use, like if this is for June, then we will use only rainfall of June month for all the years, and we will see like based on the climatological mean or long-term mean, how a particular year departs, right? What is the standardized departure? And that will give us an idea like what is the standardized precipitation. So this is like 1 month. If you look at 2 month, or as I might have shown you in this slide, here I have used 1 month, 2 month, 3 months, 4 months. So what 1 month SPI ending in August tells us, this is the situation of August rainfall, right? So that tells us that in August there was a drought in Odisha, Chhattisgarh, part of Madhya Pradesh, Gujarat. 2 month tells us July and August combined. So what is the condition of July and August combined? 3 months, June, July, August combined. Similarly, if we say 4-month SPI at the end of September, that tells us what is the monsoon, entire monsoon situation. So this figure tells us that whether the monsoon, where was deficit or where was surplus. In terms of SPI.
So that's very good actually. And my last question actually is about you mentioned actually about 1% of deficit after averaging and about 34% of surplus, which is seen, and that finally leading to a normal monsoon.
Yeah, that is very interesting, you know.
But the point which I was trying to wonder is, like, if you take in 2021 this year,
Mhm.
the prices of all the vegetables, actually today the price of tomato is nearly 100 rupees in the wholesale market in Delhi. So the price rise actually, and they are attributing it to the rainfall. But how far it is true, actually, I'm just wondering.
See,
Is
I
it-
mean,
is it,
lot of rain is not good for vegetables.
Yeah.
So September, if you recall this year, there have been floods in many regions, right?
Yes. Yeah.
So that could have contributed to this somehow. I don't know whether this is a major contributor or not.
Yeah.
Other contributors, of course, can be other factors like price hike in fuel, like
Yeah.
fuel prices, right? Diesel
Yeah.
and petrol, and they also directly, you know, contribute to the food prices.
Okay, thank you. So thank you very much, Professor Vimal Mishra. It was an excellent presentation and very educative. It was quite educative, at least for me. It was a new topic, but I could learn many things actually from this talk. And I also believe that the participants, though today actually the TropMet is going on parallelly, I believe that the recorded version of this video will be watched by many of the participants. And it's really
No
good.
issue, no issue. It has been
Yeah.
a pleasure
Yeah.
to sort of give this presentation.
Yeah.
And thank you for inviting Professor Bhaskaran. Thank you.
Yeah.
Thank you.
Thank you very much, Professor Vimal Mishra. Thank you very much.
Okay, take care. Bye-bye.
Yeah. Bye.